Hi everyone. Today I'll explain the usage of LINEST function for polynomial regression. To demonstrate this, I have a set of data showing the variation of stress along the radius of a cylinder. So this is a hoop stress variation along with the radius of the cylinder. So as the radius increases, hoop stress is decreasing. Now this variation is, you can observe that it's not linear. There is a drastic decrease in stress as the radius increases. So there is a sudden decrease in stress as the radius increases. So this variation may not fit a straight line. So you can go for a polynomial. I'll go for a polynomial of order 2, that is a quadratic equation with the given data. So to do that, I'll use a LINEST function. So LINEST function, when you go for polynomial of order 2, you will have 3 coefficients. So 3 columns you should select, and based on whether you require additional regression statistics, you need multiple rows. But if you are not interested in additional regression statistics, and if you require only the coefficients, you can select only 3 columns and 1 single row. So I have already marked these 3 cells, and here I'll get the coefficient A. Your equation is of the form y is equal to ax square plus bx plus c. So this is a second order polynomial. So LINEST function will give the value of a, b and c. So to get that coefficients, I need to select 3 cells. So I'll select these 3 cells where I'm going to get the a value here, b here and c here. So after selecting these 3 cells, you can go for equal to, then LINEST you can select LINEST, known y values you can select, then comma, known x values you select. Now after selecting the known x values, you have to mention that you require second order polynomial. To do that, you put a caret sign and open a flower bracket, then write 1 comma 2. So 1 comma 2 and close the flower bracket, and then close the bracket. Okay, so LINEST, select the known y values, then known x values, put a caret symbol, and inside the flower bracket you mention 1 comma 2. That is for a second degree polynomial. If you require third order polynomial, then 1 comma 2 comma 3 you should mention. In that case, you need one more column to be selected. So I have selected only 3 columns. So that is for second order polynomial. So 1 comma 2, close the flower bracket, and then close the bracket which is you open for LINEST function. Then you need to press shift control and then press enter key. So after holding the control shift key together, you have to press enter key, which will give the 3 coefficients. So here I entered 1 comma 2. Suppose you write 2 comma 1, then the coefficients will interchange. So usually you can give 1 comma 2. So this will be the coefficient of x square, and this is a coefficient of x, and this is a constant part c. So this is the equation. Now you can use this equation to interpolate the stress value corresponding to any other radius. So I'll find out the stress. Stress is equal to a you can select this, a into x square. X is a radius. Radius I'm going to enter here. So I'll select this cell reference and square. I'll put the caret symbol and to plus. And now b value you can select from here, that into x. X is once again the radius which I'm going to enter here, and then plus c value. C is here. After entering the equation, you can press enter key, which will give the value of stress. But this is for 0 radius. 0 radius means x is 0. So that means you are getting the constant part. When x is 0, these two are 0, getting the constant part. But x is equal to 0. That means the radius 0 has no relevance here. I'll put any value in between this. Say like 132, which is not tabulated. I'll enter 132. You can get the corresponding stress. So when it is 132, the stress is 7.46. You might be getting some higher value because this is not perfectly fitting the quadratic equation or second order polynomial. So I'll try another value, say 112. I'm getting 52.21, somewhere here in between this. So this is how you get the interpolation done using the second order polynomial. How do you know that it is suitable to use for a second order polynomial? You can get the R square value and F statistics. So for that you need additional regression statistics. So to get that additional regression statistics, you should select 3 columns and 5 rows. So I have already marked and arranged this area for getting that additional regression statistics. So I can select this, and then you can type equal to LINEST function you can select, then select the known y values, comma, then known x values you can select, that is a radius, then put the caret symbol, flower bracket you can open, you can type 1 comma 2, then close the flower bracket, then comma. Now you should get the false for b2 set equal to 0, that is constant part. This you want to set to 0, then that is not required for us, we will give true, comma. Then again you should give true for additional regression statistics. So I'll give true, close the bracket, then holding the control shift you have to press enter. So you are getting all the regression statistics. You may get something like this. I have already formatted the cells. So this cells you are not going to get any data. Okay. So the remaining cells you will get the data. So this may be displayed differently in your this thing. You can select white color for the font so that it will not create any confusion. I selected white color for the font. Now these are the coefficients as usual what you have got here, 0.045, but you are having more number of digits. You can, if you want, you can round up to 3 digits. So this value, that is coefficient of A first, then B, and then constant part. This is standard error involved in calculating these coefficients. And this is R square value. R square value is 0.986. That is 98.6% of the variation in dependent variable, that is stress, is explained by the independent variable, that is a radius. So this polynomial fit is suitable. And also F statistics. This also explains the relevance of the fit. Higher value is preferred. This represents F statistics shows the suitability of the model. Higher value is preferred. So you are getting a 252.85. That is okay for us. And this is a degrees of freedom. That is a number of data minus 1 minus polynomial fit you can reduce 2. So it is 7 degrees of freedom you get. Then SSR and SSE. This is SSR and this is SSE. That is the sum of the squares of the regression data from the mean data. And this is the sum of the squares of the residuals in the data. Out of this, we require these coefficients and R square value. This is important. So coefficients and R square value is important for us. So rest of the things are a part of this. So after getting this, you can use these coefficients for the interpolation. I'll also show the trend line for this data by plotting trend line. Insert. I'll plot a trend line here. So this is a variation of data. I'll plot the trend line here. Add trend line. I'll go for a polynomial of second degree. It's already second degree. Then display equation and R square value. You can see the equation here. I'll select 12 font and make it bold. So this is the equation we are getting, 0.0455. That is a coefficient of x square. Then this is coefficient of b and constant part. And R square 0.9863. So that value. Most of the data is fitting the line. So there is some deviations from actual data from the curve which you have fit. So this is a polynomial fit. This is how you fit a polynomial through the given data. So using LINEST function. So LINEST function, without actually plotting the trend line, you can get the values, coefficients, and you can use for the interpolation or forecast. You can also get the additional regression statistics, which will explain the suitability of the model. That's all for today. Thank you for watching.